Hey everybody, I wanted to make a quick tutorial showing how you can create one of these use VEX expressions snippets, as well as the spare parameter button. In our scene here, we just have some points with random velocity assigned to them. I'll start off by dropping down a subnetwork, and we can dive inside. I'm going to create a pop VOP, but if you were working with a pyro solver or a smoke solver, anything like that, or if you're just working with gas fields, you can use a gas field VOP, and everything should work the same, aside from when you use the bind node, you are binding in fields, whereas in a pop VOP you're binding in attributes. I'm going to attach this here, and I'll create an output node. We can delete these, and we can start off with a snippet node. This is going to be where our code snippet lives, and we will have this promoted out to the interface, or the parameter window rather, on our HDA. So the next thing we want to do is we want to drop down an if block. And we want to create some kind of conditional for this if block. I'm going to name it do VEX. And I'll make our label use VEX expressions. Okay, so let's give this a few attributes and variables to work with. I'll start off by binding in velocity. Now with this workflow, we're binding in an attribute, but we're sort of translating it into a variable, and we'll bring it back out as an attribute later, and I can try to do that. I'll also create a parameter called foo, and that will just be a placeholder variable for us. I'm going to go ahead and name these just so we can keep track. I don't think you have to name them in the if blocks, but you should name them here. In fact, you have to, because you have to declare what the variable will be called. Okay, and we will bind to export this variable back out as v. With this workflow, you can read in attributes. So if I wanted to, say, multiply our velocity by age, or something like that, I can call that in the attribute. I just can't make changes to an attribute unless it's been brought in and binded out. So that's just something to be aware of. Okay, so let's go back outside here, and I'm just going to go into our parameter interface. I'll start off by, and I want to make this quickly a toggle. I'm going to bring that guy out here, and I'll bring foo in as well. I'll press apply. So we can see here we have use VEX expressions, and we have foo. I'm now going to drop down a string, and I'm going to call this local expression. I'm going to turn off the label, I'll enable multi-line string, and I'll set our language to VEX. We can then copy this parameter, dive inside, and paste relative references here. So we now can type into this and it will act as a wrangle, and again it will rely on this use VEX expression. So just to clean things up, I'm going to copy do VEX here, and I'm going to hide this when do VEX is equal to 0, or off, we'll say. So now it only works when it's visible. Okay, great. So we can apply this. There's one more kind of caveat to this, or one tricky spot, which is creating the spare parameter button. As far as I'm aware, there's no easy way to do this. If we go ahead, let me just clear this up here. If we take a look at something like the pop drag, we go into its type properties, we can see here that there's some tags here that use some Python scripts to set this all up for us. It's a bit of a pain to do, and it's quite tedious, so I decided that I would create a little shelf tool which will do it all for us. But firstly, we have to create this, or convert this subnetwork into an HDA. So I'll go ahead and do that with create digital asset, and I'll leave everything as is. So we've now converted the subnet into an HDA, and I can just press apply and accept. While this is still unlocked, I'm going to create VEXpression, what is this called? Parm from channel. I'll provide the code, and maybe I think I can just provide this file as well in the description, so you guys can download it yourself. But I'll go ahead and click it while our HDA is selected and unlocked. And it'll bring up this little interface, and we can select our local expression channel, which will sort of drive this whole thing. If I press accept, we can see that this button's been created. Now, it will create channels for us. So if I just say channel float test, this will work. But it's not actually going to do anything. So there's one more little step we have to do. So I'm going to go ahead and delete this, and delete this too. And so to do this, sorry, actually I should leave this open, type properties. We have to start off by dropping down, I'll drop down a folder here, and I'm going to call this advanced. I'll make it collapsible. You could have this folder be invisible as well if you wanted to. I'll drop down a string, and I'll drop down an operator path. I'll name this one bind geometry. I'll set our default to geometry. And on the operator path, I will call it VEX underscore CWD path. And I'll name it evaluation node. And I didn't spell that right, did I? Evaluation node. Okay. There's a little tag that we want to create here, which is op relative. Here, let's see if I can make that a bit more visible for you guys. So it's op relative. I'll set the value to just a period, and I'll set our default to period as well. We can apply, accept. We can see now that these are here. Let's copy the first one and dive inside, and we'll go to the data bindings tab and just paste relative references. Then under the evaluation node, I'll copy parameter, and I'll paste that here. You can see now that if I middle click, we can see the path to our HDA. Cool. I will save node type and match current definition. So now if I want to say something like v times equals to foo, this will be multiplying our velocity by foo. Now remember, we don't have to do v at v is equal to foo. We just want to say v because that's what we're sort of pulling through that if block. We can set foo to something like, well, we'll start off by 1 just so you can see what our simulation looks like by default. And let's say I want it to go 0.75. We can see that our points slow down quite quickly. Maybe 9 is a nicer result. There we go. So we can see the points slow down quite quick. So now let's see, what if we wanted to create a new float, or maybe we want to create a ramp. So let's say, we'll say bar is equal to channel ramp. We will say it'll be called bar, and we will use foo to drive that. I can then create this, and I don't know, we can just set it to something fun like this. Or you know what, maybe instead of using foo, we can show that we can use age divided by at life, just to show that we can read in attributes here. So we'll say times foo times bar. I'm just going to go ahead and give this B-spline. Cool, and I'm just going to go back up to 1 for this. Now, at the moment it looks like, oh, something's not working, we're starting off with 0, and that's because this ramp needs to be flipped. Age divided by life gives us newly born points a value of 0, so we just want to flip that. And we can see that as points get older, their velocity goes down. And if we want to say divided by point, I don't know, 6, these points should slow down very quickly. Cool. Well, I hope that was of some help for you guys. I know it was kind of a pain for me to figure out. I tried to find resources online and documentation about how to do this, and it seems like there's really limited resources, so I thought it would be worth making a little video in case people wanted to try this. Alright, well, thank you very much. Have a good one, and I hope you guys enjoyed. Bye-bye.